So on to the class stuff. So the first thing we're going to do is ask you a multiple choice question. As much as I love clickers, I don't really use them in this class because it's a small enough class and we can just do the questions the old-fashioned way by hand. So the question is, what is the number pi? 22/7, 3.14159, cosine inverse of -1, all of the above depending on your need. So we'll have you vote by carefully showing how many fingers you think is, so 1 is A, 2 is B, 3 is C, D is 4. So hold up a number of fingers. Excellent, you're all very intelligent students. Clearly it must be the last one or I wouldn't have put it up here. Now, luckily I didn't say 3, right? What is the real definition of pi? Well, C is, you would get pi for C, but it's not really how we define pi. How was pi originally defined?
A circle.
From a circle. So the circumference of the circle is pi times its diameter. And so that was, the Greeks discovered that. In a sense, we discovered pi. And it's an interesting number. And of course, it's an irrational number, so its decimal representation goes on forever. Why do I mention this? Well, we're going to be talking about series. And one of the first uses of series is to represent numbers. And we often forget about this and don't think about it, but for instance, if I was to take the number 2316.2, how would I write that out in powers of 10? 2,000, yeah, but be fancier. Use exponent notation. 2 times 10 to the third. This is an interactive exercise.
Plus 3 times 10 to the 2.
Plus 3 times 10 squared plus 1 times 10 to the 1.
Plus 6 times
0 plus
2 times 10 to the 2.
Perfect. Notice what I've just done is a series expansion in powers of 10. Right? In principle, I could write this using series notation if I wanted to, of the sum of an 10 to the n from n equals -1 to 3. Right? And I have my an's are the powers out in front. And when we're doing this, this is one of the things to understand in physics. And what we do with these numbers here is physics, what we care about the number is really either the error or the precision that's involved. We're rarely dealing in an exact number. And this is something, though, that's important to understand when we go to Mathematica. So if we're working in Mathematica, and I want the number pi, one way to do it is I can actually make it look like the Greek number pi, but I just typed escape, pi escape. So using the escape command gives you a lot of the shortcuts. Shift enter executes what I'm doing, and it tells me pi is pi. If I do 3 times pi, which I can also get pi by doing capital Pi. Now Mathematica is pretty smart these days. In Mathematica 9, once you start typing something, it's going to give you choices. And that's helpful because you could just select them. But I just want the 3 times pi. And notice it tells me it's 3 pi. Mathematical wants to work in exact numbers. 3 is an integer, it's an exact number. Pi is an exact number. However, if I do 3.0 times pi, 3.0 is not an exact number as far as Mathematica is concerned. I've used decimals. I'm telling it I'm now doing numerical approximations once I have decimals. I could have also just done 3 point. I don't need the 0 there. And now it's going to give me a numerical representation. And if you've done a whole bunch of stuff and you haven't put any decimals in and it gives you something like 3 pi, but you want a numerical approximation, the command you use to do that is n. So functions in Mathematica works on brackets, and they always start with a capital letter. So n is to give me the numerical value of pi, and it gives it to me. And you can change the resolution on this and get more digits or less digits. The other cool thing about Mathematica is I can go back to old expressions using the percent, and suppose I want to see what output 2 is numerically. I can do %2, that's output 2. A double slash will execute whatever function I put here on whatever's in front of it. So now I do double slash n, and I get 3 pi. So these are some of the things that you'll see in that intro tutorial, and some of the things we'll go in more detail tomorrow. But you want to get used to some of these cool things about Mathematica. It deals in exact numbers versus approximate numbers. It allows you to do numerical values. Percent allows you to go back and use old inputs. And the // is if you forgot to do something. Say you wanted it to make it numerical, but you forgot, you can do it after the fact without going back and retyping with a //. And this works really well with things like simplify, expand, series. There's a lot of functions for manipulating how things look that you think you're going to get a nice answer, you don't, and you want to manipulate that to make it nicer. And then you just do // on it. So
Can we do it like capital N and for closet, like 3.0?
oh yeah, you can put anything in the capital N expression. Whoops. And there it works. You can put an integral in here. Because your integral might come out symbolically and you want it as a number. You can put anything you want in there and Mathematica will handle it. Any other questions on this?
What does the 2 represent? Like %2, is it like the second?
The 2 is this output 2 right here. Okay. And if I do just %, it'll do the previous output. If I do % in a number, it finds that output and operates on it. So the main idea of all of this is that there really are 2 uses of series. We use them to represent numbers, and we use them to represent functions. And that's what we're going to talk about today and in the next lecture.